solve that for x. We're gonna do, okay, take it up, step it up a notch a little bit. We're gonna go 4 equals 8 to the x plus 2. Now in this one, can I change 8 so that it's a base of 4? 4 to the what's 8? Nothing, at least no whole number. Okay, so what can I do? Still want to use the same idea, didn't be the same, change them so I can make the same base. So what could I do? Change which one? The to 12, you said? Oh, to log form. I still want to do the same base. So what could we change it to? You guys at home, any ideas? You guys in here too, anybody? Just because that this 8, it's almost like PEMDAS. Think about PEMDAS, right? You got to do a certain order, right? I'd have to deal with the exponents first before I divide. That's why I can't divide that.
Couldn't you make the 8 2 cubed and then the 4 2 squared?
Oh, so we can change both of them. So that becomes 2 cubed. That, sorry, 2 squared and 2 cubed. Now they're the same base. So we change both numbers in this case. But now we still have x plus 2 over here. All right, so guys, now the next step is when I've got an exponent outside of an exponent, how do we combine those? What kind of math do we do there? Multiply. So basically you're distributing that 3 right there. What you got? That looks good. Yep. Okay, so now what I can do is I can cancel a 2 now, but I'm going to go ahead and just distribute that 3 first before I do. So now we have 2 to the 2, and then 2 to the 3x plus 4, because we just multiplied that. Now we can cancel those out. Okay, now I've got just a 2-step equation. I've got to subtract 4 first, and then divide by 3. So then that's my answer, negative 2 over 3.
Wouldn't
I don't know. It's magically just disappeared for some reason and became a 6. Okay, don't worry about it. All right, I made a mistake. That was on me. So then that's 6. So that means that here we get negative 4 over 3. Okay, is that what you're about to tell me, Joe? Or whoever is online?
Yeah, it was.
All right. Okay, so I want you guys to do one more like that. All right, so let's do, do 9 equals 81 to the x minus 1. This is going to be more part D. Again, so that's part C from 924. And this is part D. Part D is more like I got 7 to the x equals 10. So like the last problems we just did, you might think, okay, we'll just change the base. But I can't change the base of 7 or 10 to be the same. So what's my other option? You guys are hinting at it before. Yeah, change the form. So let's go to log form now. So this would be log, what would be the base here? 7. What's the a value? 10, and then equals x. There's my answer. Log base 7 of 10. All right. Now, if the problem ever asks you to like, round to the nearest 10th or 1,000th or whatever, write that. But if it doesn't, just write that. Okay. You can just leave it like that. Okay. All right. So now let's focus on the core part of that section. Go over here. By the way, this is the last week for this packet, so make sure that you guys. Wait a minute. Oh, never mind. This actually has next week's packet. Next week in there. Never mind. This is good for one more week. Okay. So I take back whatever I was just about to say. All right. So what you guys are doing in this page is you're converting from degrees to radians, or you're going the other way. You're going from radians to degrees, and radians again is just another way of measuring angles. So if I'm looking at this first one, the key thing with this one, guys, is just make sure that you are going from either radians to degrees or degrees to radians, and all your answers must be positive. So notice how a few of these are negative. So that means we got to convert them to positive first, okay? So let's focus on just how to convert first. All right, so if I'm converting, if I got a circle here, and I start here, how many degrees is that? 0. How many degrees is here? Then the next 180, the next axis. And if I come back all the way around, 360. Now that's degrees, but the other way to measure is radians. So 0 is 0, right? If I go all the way to 180, how many is that in radians? You know? Just 1 pi, or 3.14. So if I go all the way back to 360, then how much would that be? 2 pi. Okay. So that means if I go from here to 180, and that's 1 pi, well, what would be in the middle? Half of pi, or pi over 2. So that means if you notice that each quarter is 1/2. So 1/2 pi, 2/2 pi, which means this is 3/2 pi, and 4/2 pi, or whatever, or just 2 pi. Okay, and then it even breaks down even further. So when you get to the next lesson, you'll break that down even more. There's a 1/6 pi, 1/3 pi, and 1/4 pi, and all that. Okay, but we'll just kind of have that idea first, especially this. Okay, 360 is the same as 2 pi. They're equal. Okay, and we guys watch the video with Miss Menard. She'll go in a little deeper of explaining like what a radian is. Okay, on the actual circle. All right, but I'm just going to kind of focus on what you guys need to know right now. All right, for this assignment. All right, so if I'm going to convert a degrees to radians, let's say I'm converting 70 degrees. Well, we just said that pi is equal to 180. So I'm going to use that idea, that ratio of pi over 180 to convert degrees. So all I do is pi over 180, and I multiply that times my degrees. Now, what I can do is make this a fraction. That way I can kind of multiply across. So 70 times pi, and then 1 times 180, and then just reduce it. So now I'll reduce both of these by 10. So 7 pi over 18. Okay. Now, if I want to go the other way, so that again, that's if I'm going from degrees to radians, D to R. All right, let me erase this since you already got that idea now. Zoom out just a little bit here. Now, let's say I'm going from radians to degrees. Well, it's the same idea. Let's say I'm going to convert 5 pi over 6. Okay, well, I just multiply the same ratio, but I flip it. All right, Now you'll see what happens is that when I flip it, I have pi in the numerator, pi in the denominator, which means what happens to those? They cancel. Okay, now on the top, multiply the top, 5 times 180, 5 by 6. I'm gonna divide the 180 over 6 first. So 180 over 6 is 30. And then 5 times 30 is 150. So 150 degrees. Okay, so basically you just use that ratio of pi over 180 or 180 over pi to convert back and forth. Now, if I have, let's say it's negative now. Let's say I start with negative 50. And it's asking me to put it in positive first, right? Well, I got to convert that to a positive angle. So what do I do to negative 50 to convert it? Right, add 360, you find a coterminal angle. So I add 360, I get 310, and then I do the same steps. Okay, so then I just multiply pi over 180. Okay, reduce it, and then find your converted answer. Now let's say you're doing that in radians though. Let's say you're starting with pi over 6. Well, here I add 360, but in radians, what are you at? What's the same as 360 in radians? 2 pi. Okay, see the issue with that? Can't add a fraction times the whole number, so what do I got to do to the whole number? Make it a fraction and find a common denominator. Okay, so here, what do I multiply this times? You guys remember how to find a common denominator? What do I multiply the denominator here times? So they're the same. Yeah, 6. Do it on top and bottom. So now I got, and remember, this is a -1, by the way. So I'll just write -1 pi over here, just to remind you. Plus 2 times 6, so 12 pi over 6. Okay, now -1 plus 12 pi over 6. All right, so what will the numerator be? What will go on top? 11 pi, and what goes on the bottom? 6. Remember, don't change, don't add the denominator, keep it the same. Now, I would have to go through the steps of changing it, okay? So you guys got one problem like that, that's number 7, where you're gonna have to add 2 pi. The rest of them, you're not gonna have to do that, okay? But you will have one that's like that, okay? Okay, lastly, this section here, where it says find all the possible values of each expression. So what you're gonna do is, if you notice, it's already in tangent, it's already in inverse, like it says cosine inverse of pi of square root of 3 over 2. So what you'll do, and I know it says find all possible values. You know what, matter of fact, just cross that out. Just say find values of each expression in radians and degrees. So you guys, you're just gonna find this in radians and degrees. Because in order to do all possible values, you guys need the unit circle, and that's not till the next lesson. So I want to skip that part of it. All right. So what I'll do for number 9 is I need to convert that into a degrees. Okay, and the way to do that is just take out my Desmos calculator. Remember, you go to function here, cosine inverse, and do square root of 3 divided by 2. So I get 30. Whatever calculator you're on, what do you need to make sure you're in first before you do these, by the way? Degree mode, DEG. Now Desmos is automatic as long as you're using scientific calculator. If you're using the graphing calculator, it will be in radians. So if you're using this to do the calculations, you need to go over here to the wrench and make sure that says degrees. All right, that's why I say just use this. Or you guys, you can do it on your phone or just download that on your phone basically. All right, so it equals 30 degrees. So here's a gimme for number one, but it also asks you to put it in radians. So just convert that to radians. So that would be 30 over 180, which would then be pi over 6. So I get 30 degrees and pi over 6. Okay, so that's what you guys are doing for that one. So just convert them into degrees and then convert it back to radians, okay? All right, you guys got any other questions about these? Especially you guys at home. You guys in here, I want you guys to start the first 4 problems and work on those first 4. And once you finish the first 4, number 1, 2, 3, and 4, then work on whatever else or complete that section, okay? All right, you guys at home, if you don't have questions, you guys are done. I'll see you all tomorrow.